So welcome to the September 22nd Arborist call. The so the meetings follow kind of standard format, quick intro. We do research and implementation updates from the node maintainer, Zcashd. And then we usually have time for kind of an open discussion period. We kind of talk about topics of the day, unless someone has already kind of teed up something specific they wanted to catch up on, in which case we spend, part of the time on that as well. And then, I have wrap up audience comments, et cetera at the end, but we encourage just, very casual participation throughout. Anyone has any questions or comments or anything, just raise your hand or pop them in the chat or whatever, or use the Q&A function in Zoom, and we'll definitely get everything answered for you. Arborist calls are typically about protocol development. It's where we get together to talk about, current engineering activities around protocol, any pending upgrade timelines. Of course, we just wrapped up NU5 a few months ago, so we don't have another one, don't have another one scheduled coming up at the moment. But we do talk about releases that are coming up, design, implementations, blockers, unresolved issues, et cetera. The purpose is just to make the protocol development process for Zcash more transparent and open to the community at large. Anyone can join and participate, and if there's anything you want to present, just let me know, and we'll get you slotted in. And if there's something you'd like the folks on the call to discuss at some point, you can also just let me know that as well, and we'll do our best to get it slotted in and make sure we have the right people on the call that can talk about a given topic. So, all right, other ways to get involved besides joining these calls or participating in these calls, we have a great community grants program, zcashcommunitygrants.org. Filecoin and ECC recently created a grant program that's at, it's a little harder to memorize than zcashcommunitygrants.org, but it's ff-ecc-grants.org. But there's all the info there on how you might apply for one. Happy to say we've got our first grant approved under that program. It's from Xerox PARC folks who conducted a 2-month-long Halo 2 learning group back in the summer. And they were just seeking some additional funding to continue doing some of that kind of work, outreach, develop educational materials, and continue to foster development in the ecosystem around Halo 2. Some really cool stuff came out of there, by the way, that first learning group. And then, of course, the primary async means that we use to discuss all things, engineering related is the Zcash R&D Discord. All right, and with that, I will turn it over to, not sure who's doing the update on the foundation side, but update on ZebraD. Yep.
That's me.
Hi,
I'm Teal. So we just did another Zebra release, and we were mainly focused on improving Zebra's sync and RPC performance. Currently, so we used to block on reading from our cache state, but now all of that runs in parallel. So that should make a big difference to people who are using Zebra as a light wallet D backend, and also possibly to sync performance under some conditions. We're getting ready for a release candidate. So we've started creating Docker Hub binary images for our releases. And we also updated some of Zebra Network's APIs so that they return more peer metadata. I understand some of the folks at the ECC are interested in using those for a DNS seeder. So those are the big changes in this release. And there's one breaking change for people who are using ZebraD as a light wallet D backend. We changed how the RPC threading works. So there's a config you'll need to activate to get multi-threaded RPCs, and that's all in the release notes. The reason we're not activating that by default is that it also disables port conflict testing. So you could accidentally run multiple Zebra instances or a Zebra and a Zcashd instance on the same port. Maybe you don't want to do that. And so yeah, but that config is open to you if you're happy to manage your instances and check those conflicts yourself. Otherwise, yeah, this is a pretty good release, and happy to answer any questions that anybody has about that.
So I have just a general question about some of the terminology used. When you say release candidate, would that be like a post beta release, like, or is it like just another like beta -12 or 14 or 16 or whatever?
Yeah, we'll be tagging it as a release candidate. So that means features like live wallet support and the consensus rules for NU5 and all those kind of things will be ready for final testing and ready to get audited. But just to be clear, they haven't been audited yet. So that's why it's only a release candidate and not a stable release that we're saying has been double and triple checked by the auditors to make sure that we got everything right. So yeah, but ready for final testing.
Oh, that's excellent progress. Yeah, cool. Very good. All right. Excellent. Thank you, Tior. Okay, I'll move on to Zcashd. And let's see, major updates. As we've mentioned on several Arborist calls now and through forum updates or whatever, I mean, our focus has been on addressing the increased load that we've seen in a few different ways. We won't go into the details on that. We put out a couple of releases of Zcashd that made various performance improvements to scan performance, block propagation, et cetera. Our current engineering focus is on a few things. The number one priority is a faster sync for our mobile SDKs to kind of help out wallets that are built on those SDKs, which are Edge Unstoppable and Nighthawk. So that's our number one priority. Kind of the current plan on that is to roll that, improved sync out in a couple of SDK updates. I guess there could be potentially more than two, but at least two. The first update will also have included with it support for unified addresses in the SDKs. The reason for that is quite simple. Before we shifted priorities to focus on a faster sync, our priority was supporting, all things in NU5 in the SDKs. So unified addresses first, and then of course Orchard support. So we'd already done, a fair amount of work on unified addresses, and then when we shifted focus to work on the sync, it was just easier to build on top of that than it was to, either A, strip that out or start from a different base and then try to, merge it back in later at some point. So in this first update that we put out, there'll also be support for unified addresses and an incremental improvement to sync. We also have had reports, and we've actually been able to recreate it internally. Some instances where we would have increased what I call concurrent memory utilization during syncing. So you'd be running along at what you would deem kind of a normal reserve set size, and then all of a sudden your memory usage would just kind of spike up. And in some cases, depending on the situation, the node might even OOM, so be out of memory killed. But we've identified 3 memory reduction optimizations. We're in the final stages of testing the third one, just kind of verify it has the intended effect that we'd like. And once we're satisfied with those 3, and we've identified any remaining items we want to include, there are a few other performance improvements we've identified that we want to include in 5.3.0. We'll roll those up and get those out as a new release of Zcashd. And then the third item is we're continuing to do some work around ZIP 317. Nate's on the call. He's been kind of on point for us to do some kind of nuanced research, if you will, around fee mechanisms in general, but ZIP 317, since that's a community submitted proposal. We always kind of had on our loose roadmap to investigate fee mechanism changes that might be consistent with something like an EIP 1559 style mechanism. But at any rate, Nate, is probably the most well-versed in fee constructs and mechanism that we have. So he's been leaning in on that. But essentially, there's 3 things that are kind of important to us or on our radar. One, we want to make sure that fees are equitable and consistent. And I put in there regardless of, transaction count / inputs outputs action split. And by that, I mean, we have this increased load. It's shielded. We don't really know anything about it. And we just want to make sure that that we make any kind of fee changes is kind of equitable and consistent. So if you're sending, one transaction with 1,000 outputs, or 1,000 IOs, if you will, inputs, outputs, actions, whatever, versus 10 with 100, that fee ought to work out to be the same. So there's no penalty for having more transactions or less transactions, and there's also conversely nothing to really gain associated with that either, right? The second thing that's really important to us, we want to avoid unnecessary impact on, I don't know if you could call it a normal transaction or a smaller transaction, but maybe the more common use case if I'm sending, some Zec to a recipient or two, so we want to make sure that we don't unnecessarily impact transactions that are not necessarily causing us any kind of concern. And then, a big item is UX issues and concerns and thoughts. You really need to think through those at the same time you think about things mechanically, right? It's one thing to say, here's a mechanical fee implementation, but then another thing, because fees have been historically just negligible in Zcash, what's that UX around that? It's kind of easy to see, well, if I'm sending to one person versus 5 or 10, you see directly I'm doing this and I'm using more resources. On the input side, however, you might want to send 10 Zec, so you might have one note with 10 Zec in it, or you might have 1,000 with 0.01 Zec in it, and that would be a ton of inputs going into a transaction, and that might be a little unexpected for you because if your fees suddenly went up, because you don't really have control of your input notes, definitely on the output side of things when you're getting ready to send, you do. So anyway, just to sum that up, that's some of the things we're thinking through in addition to just the mechanics of fees as well. So Nate, I don't know if there's anything you wanted to add to that or just to provide an update on some things you've been working on.
Yeah, so one of our new engineers, Greg, has been doing a lot of great on-chain analysis of recent transaction arities of different kinds, like shielded or transparent, so that we can ask questions like, well, if we saw those same transactions, but we had the ZIP 317 fees currently enforced when those were happening, how many of those transactions would be below the threshold? And just the initial results from that look like that a fair number of transparent transactions would be below the threshold for like various parameters we've been looking at. So the next thing we need to do, in addition to like reaching out to all the wallet vendors to see if they can adopt this fee change, we also would benefit from figuring out how many of those wallets might use Bitcoin style fee escalation. Because if they do and they still don't adopt this change, then their users may still be able to use Zcash because their wallets would adjust their fees sort of naturally given enough time. But we really want to kind of understand that. And then I guess one other thing I just want to say is that the parameters, so the proposal is like setting these hard-coded parameters, and it's replacing a standard fee that's already a hard-coded parameter. And since it's hard-coded, if it's too low, then it isn't going to alter anyone's usage. And if it's too high, it could hamper adoption because some users will balk at that transaction fees are too high. So it's sort of a balancing act, but because it's a hard-coded thing, I sort of expect whatever we pick is going to have some impacts, and we'll want to be observing those closely and considering that we might need another change in the future to change those parameters. Or down the road, I would like to see something that is less hard coded that could adapt to the actual usage of the network, but that is a lot more work. So that's totally out of scope for 317.
Right.
It's just on my mind that whatever we pick for 317 is likely to be either too high or too low at certain times. So, yeah.
Right. Thanks, Nate. Dara, your hand was up.
Yeah, I just want to say that we made a lot of progress on the actual zip sort of editorial issues and clarifying the formula in the zip sync on Wednesday. So there's a PR to make those updates. Yeah, that's a PR on Aditya's to Aditya's branch. Nighthawk 24.
Okay. All right. Nate.
Oh, sorry. I kind of forgot like next steps. So in my mind, the next steps would be begin reaching out to wallet vendors as soon as possible to explain this potential change and figure out how likely it is that they would adopt it. And then the other is I want to clarify a lot or suggest parts of the proposal around deployment stages. So for example, if there are a significant number of Bitcoin wallets that adjust their fees in response to what they observe happening, and we are able to get other wallets to just adopt the change and deploy that before there's any sort of enforcement, we might be able to notice if some of the other wallets are dynamically updating their fees. That would be really helpful to know if we can't determine that their developers are just going to deploy the change.
Right. Excellent point. So whatever we might do, you know, to just reiterate, it'd be great to have a kind of a strategy for rolling that out to gather feedback at every little possible stage we can. And by feedback, you know, one is obviously talking to partners. Is this something that you could adopt? But then two is like continuing Greg's like on-chain analysis to see, okay, what behavior are we seeing now? Like what has changed? Is this having the effect that we wanted? Or, you know, and as important, are there any surprises? Like is something happening that we didn't think would happen and we didn't want to happen? You know, so it's a great way to learn before there's like a, you know, any like enforcement mechanism in place. So, okay. All right, let's see, was anything in chat? I think that was Dara. Yeah, Dara posted a link to that PR. Excellent. All right, any other questions, comments about any of this on the node side of things, Zcashd? All right, well, that is, I'm gonna stop sharing. That was my last official slide. Just wanted to kind of give a brief update. You know, as I mentioned, the big thing for us is, you know, is focusing on performance improvements and mitigation of the increased load. So that's why essentially everything we're talking about or mentioning is related to that in some fashion. So, cool. All right. Anything anybody wants to catch up on while we're all on the call that we haven't already touched on?
I mean, it might be interesting to go into a little bit more detail about what the problem was with the memory usage.
Yep. Okay.
So basically, well, Strad is probably better able to explain. Do you want me to explain or?
Yeah, sure, I can.
Okay.
So in, I think it was 5.2.0, as part of fixing the other the syncing performance problems, we deployed batched and parallelized trial decryption into Zcashd. So we already have a separate thread that processes wallet updates, and that was done in response to an earlier security issue where because it was happening in the same thread as the main chain update thread, you could do like remote timing attacks, which was not good. So pull that out into a separate thread. And so we now have a separate thread that handles that. And so now it essentially will like lock on the main thread to grab updates from the main chain, like what's changed on the main chain since the last update. And then we'll drop that lock, process that. And then once it's done all that process, it waits for the next available slot to sync and grab the next chunk of updates. Now, the problem that we were having was that on machine, like it does that on a second boundary. So every integer second, it will ask for another update. But if it takes longer than an integer second to process those updates, it then has to wait till the next integer second. And so what was happening was the time to scan a block of updates from the wallet was taking longer than the wallet scanning time was taking longer than the chain scanning time. And what the effect that this was having was that the amount of essentially the wallet chain tip was getting behind the node chain tip. And so every time it hit in a second boundary, the amount of delta between the wallet chain tip and the node chain tip grew. But the way that we did batch scanning was we just like, cool, throw everything onto the batch to begin with, and then it's all ready for when the scanner needs it. But by throwing it all on at once, that ended up being quite a large memory load. And as the combination of the two growing over time, it would just OM. So the fix to that was essentially manual implementation of back pressure. So we now only, like we still grab like the chunk of data to work with for the wallet, but now we only put onto the scanner up until we hit a memory threshold, and then we start interleaving the batch scanning with the pulling off that. So that's great and does that. Then we identified a memory like consumption issue that basically wiped out all of that and made it pointless. We still have it implemented, but the core actual problem was that after batch scanning was complete, so because it's parallelized, we have to send the results of it back to the main thread to pull in per transaction. And so for each output, we were sending back an option of did it decrypt or not. And if it did decrypt, here's the note. Now in the limit where you have very few notes, most of those are going to be none, but of course they were the size of a decrypted note. So we were storing like 600 or 700 bytes for each thing we failed to decrypt, which scales with the number of on-chain outputs rather than the number of outputs you actually decrypted. So the simple fix to that was to not return it as an option and only evaluate only send something back when you actually got it. And the reason that works is because we use a crossbeam channel for this, and the crossbeam channel, the receiver you can treat it as an iterator, you can consume it as an iterator, and when all of the items in the channel have been consumed and crucially all of the senders have been dropped, so the channel is essentially disconnected, it will end its iteration. So we now treat, instead of sending an explicit none to report back that trial decryption failed, we just close the sender channel, and that acts as an implicit signal backwards.
That was very thorough. Thank you.
Now the memory spike looks like spiking memory while we're doing trial decryption, and it sort of like drops back down to nothing.
Nate, go ahead.
Was that option in C++ or Rust?
The option was in Rust, yes. And I was somewhat surprised that I hadn't seen that particular lint you're referring to, where, yeah, you'll normally get a lint when it's one size or the other. But I think that is just, yeah, because option itself is it's sort of like it's its own enum. Like if we were implementing this as an enum, we would get that lint. But I guess they don't have one for you are making something very large optional.
Yeah, maybe it's a special exception for options, since it would trigger every time you had an option of any large.
Yeah, and sort of like the problem here is essentially a combination of using this option with a crossbeam channel specifically, like, we were using an unlimited channel, but that doesn't really matter because the size of the channel is based on like the number of outputs, and the number of outputs is limited by the block size. You can't fit a transaction with more outputs in it than you can fit in a block, so it's already inherently limited. But it's implemented as a linked list internally, and the linked list has like a minimum size that's used that's based on the size of the items that could go into it, which they allocate even when the items aren't there yet. So yeah, it's sort of one of those ones which is like it's a combination of things that stack together and cause it.
Yep, and we're testing those changes right now, actually. So I have it running right over here.
Yeah,
because for some reason I've been able to find it more often than anyone, I think.
And as a side effect, we've now got a few extra metrics added into Zcashd as well. So you can track like the throughput of the batch scanner. You can track like the memory usage of it, and you can also now track which now seems like an obvious metric to have, but you've now got separate metrics for the chain tip synchronization point, which I think is the same. It's the same metric for Zcashd and Zbra, and then there's now a separate metric for what's the height of the wallet to scan to, so you can more easily observe when this behavior is going on. So we've noted some other potential issues that synchronization issues we need to deal with as a result of this, but this addresses the primary issue that users were having.
Yeah, about that lint, I think it's allowed by default, and also I think it only happens when you're defining the enum. In this case, we're not defining option.
Cool. All right. Yeah, and great work on that, by the way. That diagnosing these kind of things is not trivial, but the team did an excellent job. Particularly, I think Stratandera spent a fair amount of time pairing on it and diagnosing some heap track files, and it was really great finds. And then also there was one additional topic. So Conrado, I apologize. I usually check the Discord before these calls and make sure there wasn't any suggestions from folks. But Conrado wanted to have a chat about Zcash script maintenance. So I'll just kind of turn it over to you. And
sure, no worries about that. Yeah, I prepared a small slide. Let me organize my windows. It's my first time sharing a screen in Zoom, so
I do it all the time, and I still have to hunt for it.
Yeah,
so it should be down toward the bottom, depending on your client.
Yeah, it's select a window on an application that I want to share, but it doesn't show anything, just a whiteboard. Right. Maybe portion of screen. Let me see if that works. This is weird, but let's see if it works. It's working.
We're just seeing a black screen. Oh,
yeah, it says you've started screen sharing, but it just kind of has a blank screen basically.
Yeah, I'm not sure. It's not,
I need to share it, Conrado.
Sorry?
Or at least try. Do you want me to try to share it?
Yeah, that will work.
If you stop.
Yeah.
Do you guys see that?
Yep.
Oh yeah.
Yep.
Looks
Thank
good.
you.
Cool.
Yeah, I can go to the next one. So basically, the thing I like to discuss a little bit is Zcash script, which is a crate that Zebra uses to verify signatures in transparent transactions. So it basically wraps a piece of C++ code that is inside the Zcashd repository, which is zcashscript.cpp, So there's this crate, it generates a Rust binding for the C++ code. So the issue that we often have is that every time Zcashd updates, for example, Orchard or Halo 2, we need to update the crate to use the same versions that Zcashd is using. And the reason for that is that Zebra also uses those dependencies, and so that we don't have duplicated dependencies with different versions, we need to do that. And this can be a little bit annoying. And also another problem is that the crate repository needs to copy the Zcashd source code because we need to include it. And this is also a bit annoying. You can use Git subtree or some modules, but each one of these options has its own problems. We've been switching between them for a while. So I was discussing some of these issues on Discord, and the thread suggested that maybe Zcash script could live inside the Zcashd repository. You can move to the next one. Dodger, please. I think yeah. So to explain first, just explain how the crate works. So include the source code with Git subtree, we generated the bindings with bindgen. In order to build the C++ files from Zcashd, we use the Rust build script, build.rs, uses cc build to compile the files and link them to the crate. But recently we also had to do a small change because the Zcashd now generates some of their own bindings, its own bindings, using CXX. And we need to include some of these generated files. So we had to basically replicate the logic of generating this code with CXX. So that's how currently it is. Next slide, please. So the first solution that I thought would be, maybe we could remove the dependencies from the Zcash script, the C++ file. But we discussed this on a zip sync, and it doesn't seem to be, I mean, it's feasible, but it's difficult. The reason it requires those crates because it needs to decode a transaction. And to decode a transaction, you build a transaction memory, and this transaction has some fields, which are, Orchard, Halo 2 proofs, stuff like that, which use types from those crates. So to remove, I thought of, maybe the caller could compute the sig hash, for example, and provide it to the crate, but that would require exposing low-level APIs from Zcashd, which is something that's not, I think Strad explained, that's something that they don't want to do, and that makes sense. It's also kind of could be dangerous because maybe the user could provide the wrong sig hash. So yeah, this doesn't seem to be a good solution. So next slide. Maybe the simplest solution would be to simply move the crate as is into the Zcashd source. The advantage of that would be we no longer would need to keep a copy of the Zcashd source. It will be already there. But we need to think about how to build the crate. So next slide. So we could keep the same build system that the crate already has, using build.rs to call cc build and manually generating those code, the code that's generated with CXX, which we already has, right? We already have. So that's simple, and the user, if in our case Zebra or anyone who is using the crate, they just need to import it and they will build. They need a C compiler, but most of developers have one around, but they don't need anything other than that. The downside is that you still need some duplicated logic for building the library and generating the code with CXX. Next slide, please. So the another option would be to integrate with Zcash build system. So we would just copy the bindings, the source of the bindings into the Zcashd repository. We could even migrate to Sdks to make things simpler. I don't think that would be hard. We would then not use CC build. We could, just compile Zcash and link to the object files that we need. I was looking to the Zcash source, and I noticed that there's an option to build a libzcash script library, which is exactly what we would need to link with. So that seems to be an option. We then could reuse the success code. We would need to call it to generate those bindings again. So yeah, we need less repeated logic. So the downside maybe is something that I don't fully understand how it will work, but I fear that in order to compile Zcash, you need a bunch of build dependencies. I was just compiling today just to see how it works. I noticed that it even downloads the C compiler and builds a lot of stuff, even the Sdks generator, it builds on build time. So I'm not sure how this will work. If someone has a Rust code, then they want to use the Zcash script Rust crate, and when compile the project, they would to install all the build dependencies that Zcash needs. So maybe there's the build system of Zcash could provide like an option to just build the libzcash script library with less dependencies, but I don't fully understand how that will work. So this basically the options that I see. So my question is, does this make sense? Did I miss something? And do you have any suggestions of what is the best approach?
Dara's hands up first, I think, and then Strad.
Slightly, yes. So I was just going to say that we consider it necessary for consensus compatibility to build with pinned versions of all of our dependencies. So we could potentially narrow the set of dependencies that Zcash script in particular depends on, that, but that's probably a lot of work. Strad will probably know how much work that is.
All right, thanks, Strad.
So, yeah, we had a good discussion about this in the in Zipsync previously, and I had forgotten at the time that just build libzcash script and then just pull it in as a static library that all the Rust people use requires building that library for every possible target, which isn't something that we want to do. Or isn't something that's really feasible to do. Cargo doesn't really have that sort of like bottling system set up. So the changes to move to like everything using CXX, I think, is a good idea in general. Now that we've managed to get it integrated, we want to move basically all of our interfaces to be built with it. There are some limitations a little bit in terms of like interoperability of certain types within CXX, which is just limitations of what they haven't implemented yet in the CXX builder. But that's like, if there's limitations there, then we can go and contribute things upstream if necessary. The main issue is just getting the right strata for the build system, because we're wanting to move as many of our foundational dependencies to Rust as possible. And in particular, things like moving Blake2B has already been done. We'd like to move SHA-2 to the Rust crates as well, if possible. For now, we've been keeping our internal SHA-2 updated relative to upstream Bitcoin just for simplicity, but it is an eventual goal to replace that as well. So what we really kind of need is like, we have, and then obviously for transaction parsing, there's a bunch of Rust dependencies there now as well. So we sort of have like low-level Rust dependencies, the C++ code that lives on top of those that is necessary to build libzcash script, Then we have Rust pieces that want to be able to use that piece, and then we have C++ dependencies that separately want to use libzcash script, but don't want to use the Rust library. Because, and this is sort of the key part to get, is that, like, due to quirks of history, libzcash script is a wrapper around a subset of the script engine. It is the C library. It is not the full engine. In particular, there is a lot of the stuff there for building scripts and things, which is very C++y and very much tied into the rest of the Zcashd system. Now, it would be nice, and I think a potential, given that Zebra is going to eventually want to do wallet stuff as well, and also we are interested in moving our wallet stuff to Rust as much as we can. There is likely at some point going to come a time where we're going to want to have a Rust interface to the script generation side of this. So that could be a direction to investigate in terms of ending up with a unified, like, actually fully break apart the strata and just have the engine and anything it needs as a sub piece, and then like insulate that from the rest of the C++ code base. That would be quite a bit of work to do, though. And so the interim, to wrap up my ramble, I think the interim most reasonable solution will be to go the sort of a hybrid of the two, where we copy the source in, so we leave most of the existing pieces behind, but we do bring in the build the build.rs changes. So there is a small amount of duplication between the make files that we use and the build.rs specifically for building this piece. But we then hook up the build system to, by default, use the pinned compiler and other bits and pieces that we normally use. Then if you're using it as a Rust library that gets published, well, then that's already just extracted the few files it needs and been uploaded as a crate. And then, well, I guess you're just using whatever compiler is on your system because you're completely outside the Zcashd code base.
Yeah.
And that seems like the most reasonable thing we can do, and to sort of strike the balance between making updates to this less painful while also making this seemingly usable. Because I mean, from a consensus point of view, the main thing that matters is that, like, everything that Zcashd uses is consistent, and ideally everything that Zebra does within it is consistent with Zcashd. So from that perspective, it would be nice for, like, compiler consistency and Clang consistency there as well. Though Zebra doesn't do any pinning of that sort, as far as I'm aware.
Right. Yeah, thank you, Strad. Yeah, I think that. Sorry, there's more. Go ahead.
Yeah, Dara's got a hand up, and then Nate.
Yeah, so let's have a long-term plan for removing Bitcoin style script, because that's the only way in the long term we're going to get rid of this complexity.
Oh yeah, if we can deprecate the transparent pool, that would make our lives so much easier on this front.
Yeah, I would really like to do that at the same time as moving to proof of stake, but that's just opinion.
Yeah. So from that perspective, there's also the we can get something to work that is easier to maintain, and then live with a bit of pain with it for a short to medium term potentially.
Right. Cool. All right, Nate.
Yeah. This is. So I was wondering, how feasible would it be to pull out the script-specific portion of Zcashd into a separate, like, repository and just make kind of a standalone C++ library? Is it too sort of interwoven into the rest?
It's very interwoven at the moment. There might be refactors upstream that make this easier that we could try pulling in, but as it stands, it is currently quite interwoven. It would already be like just to do this, it would be necessary to try and pick apart the build level aspects of it.
Yep.
And that on its own is going to be somewhat tricky, but doable because it sort of already exists. Although the way that the libzcash script works in the Bitcoin style build system is just that it's essentially slightly parallel. So it's already somewhat duplicated in that you have the regular script system as it's integrated into the main node. And then you have libzcash script, which just goes, well, I need this file and this file and this file and this file. And I'm just going to pull them across into their own build subunit. And it mostly works. We sometimes find cases where libzcash script has atrophied sometimes because we make a change in the main build system that we didn't quite get reflected. We've had this in the past where it didn't quite get reflected into the script build system. So it's already like somewhat tricky to keep them in sync from that perspective. Pulling it out entirely is not my cup of tea.
Yeah, so it might be possible to sort of extricate the script interpreter, which is the main part of validating scripts, from the script builder logic, and then would only be the script interpreter that you needed to move into this other library. It's
a bit tricky though, because the script interpreter is used for both.
Right.
Yeah. It's all of this is doable. It's just how much legwork people are willing to put in to wrench it into position.
TR.
Yeah, so I guess one thing that we haven't really spoken about is kind of testing in CI. So I guess a current experience of testing this is that we don't actually run any CI or automated updates to the Zcashd dependency. So when Zcashd updates, we often find out effectively by surprise just before a mainnet or a testnet consensus change, usually a network upgrade. And so, and it's very tricky to schedule CI in a separate repository on every change. So I guess one of the advantages for us and for anybody else who wants to use either the Rust Zcash script or the lib Zcash script is that if it was moved into the Zcashd repository, we could run some basic checks on it in CI, and we could agree on what those checks need to be. And then, we don't have to try and deal with this testing across multiple repositories.
Yeah, testing, it is possible to do that kind of synchronization. I do it in a few of my own repositories, but it's not fun. Essentially, this proposal does put it does put maintenance burden on the Zcashd developers in the moment to do that. But I think it's maintenance burden that's manageable, because it's the kind of thing that we have to do for the libzcash script library itself anyway. And so finding those things out, when they interact with the Rust component at the same time, seems like manageable. Because as far as its external surface goes, it's relatively well contained.
All right. That's good. All right, Conrado, anything else on that one?
Thank you everyone for the discussion. I think just one perfect fine option is to do nothing, right, and keep things as is if it's not if the other solutions are more work. But I like Strad's suggestion of keeping the build system and moving to the Zcashd repository. So my suggestion is to be, at some point we can create a PR, work in progress PR, with what we think makes sense for us, and then we can keep discussing that. I just don't know when we're going to do that. We need to schedule it, but yeah, that's my suggestion.
Yeah. Yeah, I think the approach to then move also actually something that might help here. I noted in Rust 1.64 that got released today, they've just merged some interesting improvements to how workspaces are defined, like being able to define common dependencies and whatnot. And so that actually I think would greatly help us here, because we have
Didn't
a
that just
pretty
drop?
yeah,
in
like
Rust?
today.
Yeah, that'll be
Yeah,
helpful.
and I was reading the release notes earlier,
Yeah, still in nightly.
and that would definitely help here, because essentially, that we would go the route of. I think the route that would make the most sense here is to have separate crates for Zcash script and LibreZcash within a workspace that can then just like share common pieces, and then we just sort of pull the bits across as we need them. Because it's also one of those ones where like the LibreZcash library component is on some level a dependency of the Zcash script library. So it's like right now, I think the way it's done is that the Zcash script just pulls in the relevant Rust files from the LibreZcash component, and then just sort of like, these are mine now. But with a workspace, we could sort of like figure out the Rust component of that strata a little more carefully, and figure out how to interleave them nicely. And then the new workspace changes will definitely help with that. And yeah, so Zcashd we try and stick with as close to latest stable as we can, modulo LLVM changes. So as long as they're still on LLVM 14 in this release, then we can just jump to that and start using it.
Okay, let's see. Okay, any other questions, comments, or anything on Zcash script or anything else, or new topic anybody wants to bring up? Nope. All right, very good. Okay, great discussion. Thanks very much, everyone, for joining in. Well, like I said, we'll have the recording up probably in a day or two. Maybe early next week, actually, at this point, though. But yeah, everyone have a great weekend, and we'll catch up in Discord. Bye.
Thank you. See ya.
Bye, everyone.
Bye.
Cheerio.